Awesome. Well, I'm very excited to be here. Yeah, and thanks to everybody for organizing this. I'll just go ahead and get started. So, yeah, the focus of the day will be sports tracking data, specifically really NFL tracking data and the Big Data Bowl. I listed my Twitter there at Data with Bliss. Feel free if there are any follow-up questions to contact me there, and also I just tweeted out links to both the Kaggle competition, the Big Data Bowl, and the code that I will be sharing today. So if you want to follow along as we go, it should be easy to do so. So first of all, what is sports tracking data? Why is it important? Why is it interesting? Essentially what it is we know a sport, like for example in the NFL here, we don't just record maybe what happened, the outcome of the play, whether in NBA maybe it's a made basket, and in baseball maybe it's a hit, in hockey maybe it's a pass. We're sort of going a step further, and actually throughout the entirety of a given play or series of plays, we're looking at the XY coordinates where the players actually are, and that can give us a lot more information. And this is relatively new data. A lot of sports analytics, like other data sources might go back a little bit further. For example, there's NFL play-by-play data going back to about 1999. But this tracking data, that sort of gives more information than just what's going on in the play in terms of the outcome. That's actually giving the coordinates of every player throughout the play. That this is relatively new. And another thing to note is it's not typically publicly available. The NBA has a little bit of it publicly available, but outside of the Big Data Bowl, for NFL at least, there really isn't any source that I know of that's publicly available. And the last thing I was going to sort of say before I move on was there's sort of two types of tracking data. You can use video, which is used in other leagues such as the NBA and the NHL and soccer, where maybe you use the same broadcast, you see the video and you convert the images of the video into XY coordinates. Or what the NFL does is they use RFID chips, so literal radio chips that are going to be in the shoulder pads of every single player and in the ball, that relays to a sort of a source radio, and it'll constantly be measuring where the players are throughout the entirety of the play. So that's what NFL tracking data is based on, these radio coordinates, and that's sort of what we're going to be discussing today. So next, what is the Big Data Bowl? So it's an online, free to sign up competition. I encourage everybody who's interested after this to look at it, think about signing up. The focus is on this NFL tracking data that I'm discussing, and the goal is we give folks the data. They have an opportunity to analyze it, create new metrics, do fun stuff, visualize it, and typically what it also, like, as the league, we get to see a lot more cool new content, and also as a league, it sort of provides a pipeline for NFL team hires, and honestly also other sports team hires. It shows others that you have this skills to work with this complex data, and a lot of teams are sort of asking for this, and it's a good way to show off your skills, and provide new content and create some cool stuff. This is a very, very general timeline of what the Big Data Bowl typically is. Typically the I'm so sorry. Typically it starts in September or October. The submission deadline is November to January. Then there's judging. The winners are announced, and we're unsure what will happen this year with COVID, but typically the winners have presented in the past at the NFL Scouting Combine between February and March, and eventually the work is submitted into production by teams, by the league, and it becomes useful. So yeah, currently we're in the middle of the 2022 Big Data Bowl, which launched in late September and will go through January. So definitely not too late to sign up if those are interested. So here's a quick overview of what the Big Data Bowl competitions have looked like in the past. We've had 3 in the past. We're currently in the middle of our 4th. The first Big Data Bowl was fairly open-ended. We shared a bunch of tracking data, and we were asking folks to look at stuff involving route combinations, so sort of how a receiver might run to try to get open, rule changes, and how the rules of the games will be and their speed. The second one in 2020, the focus was expected rushing yards. And I don't know if anyone has seen the rush yards over expectation metric. That's something that stemmed from the Big Data Bowl. And last year we were looking at the secondary, and so that's defensive players in coverage trying to prevent other players from catching. So all 3 years have been very cool. A lot of very good stuff has come out of each of them, and so it's been really fun so far. And I guess the other thing I would like to note is each year we have more we have a lot of entrants. We're getting more entrants, a lot more attendees. It's growing, and we're seeing NFL hires each year. The first year we had 11, then 3, then 7. There's a cash prize that goes to the winner. A lot of countries are participating. For example, in 2020, there were 32 different countries. The reason 2020 maybe got a little bit more than the other years is this was sort of a traditional Kaggle competition in the sense that there was one metric, where other years it was more open-ended and it was more submission-based, and that's how it works this year. But yeah, participants, we get a lot of participants, and typically we see some NFL hires from it. So my final slide is I do this brief overview. I'm going to talk about the 2022 Big Data Bowl. That's the one that's going on today. Again, September to January, and essentially what participants are asked to submit is a Kaggle notebook that will have that will show sort of a analysis results. The goal is to submit a paper that gives information that someone can read and learn something new. And the theme is NFL special teams plays, which that includes kickoffs, field goals, punts, as opposed to offensive and defensive plays. And also, we also are including some external data, which comes from Pro Football Focus. So this is the first year where we actually go across 3 years, which is pretty cool. And there's a lot of cool data that we're sharing. And obviously, you can see on Twitter, you can see right here, we encourage people to check it out on kaggle.com/NFL Big Data Bowl 2022. So with that, I'm going to share a quick animation of what this data looks like. And then I think I'm going to take a quick pause for questions after I show this animation before I get into the code. So right here, we're going to look at a video of some data that we could see that's included in the NFL Big Data Bowl 2022. It's some tracking data involving a kickoff play by the Bears and the Vikings. And I'm going to sort of show what the video looks like and what the actual play looks like. So as you can see, this is before the video starts. We have some players lined up, and they align with the players lined up there. So the players in the video in white, that's the Vikings. They're in white here, and the players in dark blue, which are the Bears, are here. So I'm going to play the animation and the video at the same time. And this is just to give a sense of really what we're doing is we're just taking the video, we're taking what actually is happening in the game, and we're just translating it to data, to XY coordinates, so we can analyze players and plays. So I guess they're playing at the same time. So you can see in the video, it's moving in the ball. See, now the player has the ball and he's running up the field, and the video is not working. Sometimes this happens, but you can see now the player with the ball is running towards the end zone, and you can see that in the video and in the animation. So this is just a way to analyze what's actually happening in the game, and we now have XY coordinates. It's a good way to see how everything is working, and it's efficient. It's easier than just watching every play per se. So with that, I'm going to do a quick break for questions, and then afterwards, I'm going to get into the code.
Thanks so much, Tom. I just took a quick look at the Slido, and I don't see any specific questions on the Big Data Bowl yet. I'm going to check again, but feel free to raise your hand, and I can turn on the ability for people to unmute themselves for a second as well. And we can also save questions for this till the end as well. If
that's fine. Yeah. Okay. So if there aren't any questions, what is the sampling rate for the data? That's a great question. So 10 times a second, we do a reading. So every 10th of a second. Cool. All right. Well, if there are
one other question was, when will the Data Bowl for 2023 begin?
Yeah. So I would assume September, October 2022. Just sort of towards the beginning of the NFL season for the 2022 season. But again, there's still plenty of time left for this Big Data Bowl. So if you're interested, maybe you're going to be less busy during that time, so that might make more sense. But if you're interested, I highly encourage you to still try to check it out. There's plenty of time still to get a submission. Is there a reason why the data isn't? Yeah, the data is the NFL doesn't want to share the data. It's proprietary. Part of it is teams have access to it, and you don't want to. It just doesn't make sense to sort of give it away to everybody outside of this event. So maybe I'm not the best person to answer that question. Maybe, but yeah, we don't share it outside of Big Data Bowl. What is the error? I don't know if there's like a RMSC I can give you, but certainly there are some plays where there are mistakes. Sometimes when the ball's punted and it's high up, it might lose a little bit of connection to the radios that are stationary. I don't know if radio is the right word, but it might be a little bit harder to read where exactly it is. So that's a possibility of error. Typically, though, for the Big Data Bowl, most of the error-ridden plays are removed, so everything should be good. I guess maybe a better way to what we could say is I think it's pretty accurate to, I believe it's 6 inches or something. It's pretty close. Like it's at least less than a foot. Yeah. That seems, yeah. So it's less than a foot of error typically. So it's pretty good in that regard.
Awesome. There's a few other questions around like specific packages that I think might be helpful to cover maybe after the next part as well.
Okay. Yeah, that sounds good. So I'll jump in to my code if no one else has any questions. So yeah, I'm sharing this from Kaggle, and unfortunately I couldn't figure out a way to make it bigger. So hopefully this is readable for everybody. If it's not, I can zoom in, but I'm hoping everyone is able to read it.
That looks good to me.
Okay, good. So the first code sample I'm going to do, and this is stuff that I've publicly shared before, we're going to discuss using the Big Data Bowl data of 2022 to analyze kick attempt offset from center, which is a metric that we're creating, and you can only really create with the tracking data. So the first question is like, what exactly is this metric? So as football fans would know, kickers are part of it is a field goal kicker will try to kick a ball in between the field goal posts, as you can see in this image right here. The goal would be to make it inside, and depending on whether it's an extra point or a field goal, it's either 3 or 1 point. That's not necessarily relevant here. But as you try to make it through, if you're kicking let's say a soccer ball or a hockey puck, assuming maybe there's no goalie there, but you try to get it as centered as possible because that would increase your chance of making it. So what we're doing here is we're going to measure how close to the center as the ball goes through the uprights, a typical field goal kicker might be. And that's just a way for us to say who's the most accurate, who's best at getting it right in between the posts. Maybe there's also an element of luck. Maybe one kicker might be 90%, making 90% of their field goals, but a lot of their field goals were barely in, where another player was kicking 89% and all of their field goals were completely in. And that just is a way to say maybe there's a little bit of luck going on here, and in the future we might expect this other kicker to be doing better. So this is just a way to measure kicker skill, looking at that offset from center. So we're gonna load up some libraries, tidyverse, of course, animate. We're gonna animate some stuff, and we're gonna make a ridge plot. So nothing too crazy in terms of packages to start. We're going to load in plays data. Plays data, you're going to see this in every sport. It's sort of like a description of what's going on a given play. And in football, it's a very sort of broken up sport in the sense that you're playing and then you're not, playing and then you're not. So each row will represent a given play, a given series of like a snap, and then what happens after the snap. Players, again, that might be that you're going to see that in every sport. Every sport has players, and this is just who they are. So we look at the head of the players variable, and we just have an ID, we have their name, we have some other information. Really, we're just going to look at, we care about the ID and the name, or I guess it's the college name, but the ID and the display name, which is their actual name. This is the plays variable. You have a game ID, a play ID, you have quarter, down, distance, information like that. Okay, cool. So now we're going to load in the tracking data, and the tracking data is very big, which makes sense. You're measuring it every 1/10 of a second, and you have a row for each player on each 1/10 of a second for each play. So it's going to be very large. There's 11 players per team and the ball. So for each 1/10 of a second, you're going to have 23, and typical plays will last like 4 to 6 seconds. So and there's also some time immediately after and immediately before the play. So it grows really quickly. So that's why we have to load this in iteratively, because it's big data. So we're going to load it in. We're going to look at the head. And as you can see, we have a time, we have an X, we have a Y coordinate, we have an NFL ID, which we can match the players. And we have a game ID and a play ID, which we can match the plays, and a frame ID, which is sort of like what frame it is. So you can match it across different players on a given play. And some of these other variables we're not going to use here. We might use in the next one. S is speed, A is acceleration. So this is what the data we're going to be working with looks like. So next we're going to think about cleaning the data. So one thing to note is, and I'm going to show you a map of what the data looks like. We have an X and a Y, and this is just something that this is an NFL field. The X coordinate goes from end zone to end zone. The Y coordinate goes from one side of the field across the other side of the field. And this is a way to look at it. So 0-0 is the corner of the home end zone, where 120-0 is the corner of the visitor end zone. So football field's 100 yards between the end zones. Each end zone is 10 yards each. One thing to note, and that's what we're about to do in the next part of code, because each team will change sides at the end of each quarter, sometimes the offense and the kicker will be kicking in one direction, sometimes they'll be kicking in the other direction. So as you can see, like the X and the Y coordinates don't necessarily change with who has the ball, which direction they're going, which direction they're kicking. So one thing that it's important to do is to check the play direction. That's the direction that the team is kicking, or in this case, kicking, or the direction the offense is going, and flipping it so that way it's consistent. So if you're kicking a field goal, you're always going to be kicking a field goal the same direction in the coordinates. So we're flipping it so that way no matter what, the team will be kicking this way. That's somewhat arbitrary. We could say they're always kicking this way, but just to keep it consistent, we don't want a field goal kicker to be kicking towards this end zone, a field goal kicker kicking towards this end zone to look totally different. We want to be able to compare them apples to apples since they're essentially the same. So we do that flip. We take the tracking data. We look at, we filter for when it's the football. The tracking data also contains players. In this case, we only care about the football. Although we're interested in who's kicking it, we're really just curious about the trajectory, not what the kicker is doing it as they kick it. We don't really care about that. We're taking the football. We're looking at the X coordinate, and we're seeing, okay, where we want plays where the lag of X, the play previously. And before let me note that I'm grouping by game and play. So that way we're only looking at specific for a given game and given play, and we're arranging by the game, play, and the frame. So that way we're making sure we're looking in order. So we're filtering for plays where you have passed the 120 mark, but the previous X was before the 120 mark. So we're really, to look at the map, we're really looking right back here, and that's where the upright is located. We're filtering for the spot right when they cross this back end zone, right when they would be crossing the uprights. We're selecting the first occurrence just in case maybe it rolls after. We don't want any weirdness going on. And then we're calculating the key metric here, which is offset from center. So we're taking the Y variable, the crossfield variable, and we're figuring out the difference between it and the center, which we kind of see as the goal. We want an ideal kick will be just down the middle, as they might say. So we're taking the difference between where that Y variable is and the center. So then for each game and each play, we're only selecting these variables. We have the offset from center. So an ideal offset from center would be 0. A bad offset from center might be like 10. The goalposts are I think 18.5 feet apart. All these coordinates are in yards, which is the coordinates of football. So I think about 6 point something is the length of the uprights. So if you're outside of 3.3, if you're 3.5 and above, you're probably gonna be missing the kick. So that's not good. You want to be making it, and you want to be making it just down the middle. So we're merging it to the plays variable. We're only looking at plays when there's a field goal attempt. Removing plays when the field goal attempt was short. We're looking at the yards from the end zone just so we have a sense of how far was this kick. We want to, because if you're kicking very close, if it's an easy kick, we want to treat that differently than if you're kicking from a very far distance. And so we're calculating the kick length, which is the yards from the end zone, plus 18, which takes into account the length of the end zone and some other factors. We're joining the players, so that way we have the names. We're joining this metric that we had. So now we're only going to look at what we're interested in. We're going to look at the game ID, the play ID, the name of the kicker, how long the field goal kick was, and what the offset from center is, and that's the outcome variable. So we know that, yeah, kicking a 50-yard field goal versus kicking a 20-yard field goal, for those of you who know football, those are very different in difficulty. So we want to make sure when we're looking at this offset from center variable, we're being fair. So this is what our final thing looks like. We have game ID, play ID, we have a display name, we have a kick length, we have offset from center, and we have a description of what happened. Okay, cool. So before we sort of get into visualizing and figuring out who's the best in this metric, it's ideal to animate a play or two. So we're going to use this field from Marshall Furman's GitHub. We're going to just select a random play. Oh, I guess we're selecting a play with the minimum offset from center to give an example of. This is one where it was really like a very perfect kick. And we're joining that to the tracking just to select that one out. I'm not going to go too deep into all these sort of colors. Essentially, I'm setting a lot of colors and widths just so to make sure the field looks good. I'm setting the plot title as the play description, which is this variable, just sort of saying what happened. And yeah, I'm going to do an animation using ggplot and ggfield. I'm adding a segment for the uprights. So I'm going to animate each point, and it's going to look similar to what we saw previously, right before I took the first break. We're going to add some points, and we're going to animate what the players look like and the ball as this field goal goes in, using GeoPoint and adding some colors and some text for the jersey numbers. So this is what it looks like. So we see this was the kick with the lowest offset from center, so the best in the metric, and this is a 50-yard field goal. I think the other one so we're looking at 50-yard field goals only here. So as you can see, the field goal kicker gets it, and if you look right there, it looks perfectly just down the middle. This is about as in between those uprights as you can get. So that's what we're saying is what we see as an ideal kick. We now can animate one, but instead look at the max offset from center when looking at a 50-yard kick. So this one might be the one that was the worst in terms of being able to kick it between the uprights. So as you can see, this one wasn't really that close. It was a couple yards out of the uprights. It wasn't made. It was not a good kick. As compared to this one that was just down the middle, which was perfect, this one was not good. And I mean, another thing you can think of is if they're going to miss it, you probably feel a little bit more promise with their performance if they're missing it just outside. This one that he missed decently outside. Okay, cool. So we're going to visualize this metric by kicker. So as we saw before, we were able to merge who's kicking on a given play to this metric. And that way we have a sense of who's doing well in this metric. And for this, we'll just look at all kicks between 30 and 40 yards, just because there's the biggest sample size there. And we don't want to use a kick length that is, we don't want to vary by kick length, because maybe some kickers are just kicking easier field goals. We don't want to give them the benefit of the doubt there. So we're grouping by the display name, which is the name of the kicker. We're limiting for only kickers who have 75 plus attempts. We don't want to have a kicker who had one attempt that was perfect and be showing him as the best, when we know that maybe he wouldn't be as good if he had a bigger sample size. So we're grouping by that. We're filtering for a sample size of 75 or more, and then we're calculating the average offset from center. We're doing a ggplot, we're doing a bar plot, and we're setting the theme, labels, other stuff. And now look at this. We have a plot that will give us the kicker average offset from center, ordered from the best kicker to the worst kicker. And for those of you who know NFL football, it's probably not a surprise that Justin Tucker is seen as the best kicker. He's universally seen as probably the best kicker today, and certainly over 2018 to 2020, I think a lot of people would say he's probably the best kicker over that time. The worst kicker is Adam Vinatieri, and although he historically was a very good kicker, his 2019 season and his 2018 season, I think his last two were probably not his best. So that's why he might be not as high in this metric compared to some others. So again, we can compare, and on average, they're all making them, and that makes sense because typical kicker today is probably making 80-90%. Because if it was greater than 3, maybe we could say maybe on average they're missing, but on average it's in between the uprights, but they vary in terms of how close to right down the middle they are. And Tucker, unsurprisingly, is the best, and then you see a lot sort of in the middle. And he's the best by a wide margin, which also would agree with intuition. We're going to take this exact same data and look at it as a ridge plot, as a series of density plots. That will give us a little bit more information as opposed to a bar, which is just one average. We can see maybe some kickers are just wild. They're sometimes very good, sometimes very bad, so they look average. Maybe some kickers are just typically right at a certain range, and looking at a density plot will give us a sense of whether this is a kicker that consistently is at where it's at, or maybe he is sometimes is right on the money, sometimes is a little bit off. So we're going to use geom density ridges from the GG ridges package to plot this. And again, I ordered the exact same way by smallest average. But yeah, Tucker, we can see it is fairly consistent. And Adam Vinatieri, he probably has one of the flattest distributions. Sometimes he was really good, sometimes he was really bad. And that sort of agrees with what we saw. In 2019, he wasn't very good at all. 2018, he was decent. So this is the first code that I'm going to share. The second one, I might go through a little bit quicker, but maybe I might stop for questions here. But also people can ask at the end again. So does anyone have any questions?
I can start with reading a few from Slido. And just a reminder, if you don't mind, if you're putting questions in the Zoom chat, I love to see them there too. I just want to make sure I don't miss any, if you don't mind copying them over to Slido. But one of the questions was, what are some preferred packages for best dealing with XY data? Yeah,
so I mean, I typically just use the tidyverse metrics, but I definitely know that there are some that are pretty good. I know Ben Baldwin has a package, and I can't think of it off the top of my head, but he has a package that does some data cleaning for next gen stats data, such as what you might see in the Big Data Bowl. That's something I would suggest to start. But I mean, there's a lot of different ways to tackle it. It really depends on what you're doing, and there are some spatial packages that sometimes would make sense if you're doing for a specific thing. But sometimes, typically, what I do is I just can use tidyverse, and I guess I would also recommend some animation packages such as GG Animate, just because with this data, it's hard to even know what's going on, even if you're looking at. I like to use view sometimes to just look at what data I'm dealing with. Even that sometimes is really difficult because there's so much going on. So always using some sort of animation package to animate the data goes leaps and bounds in terms of understanding what's going on.
Awesome. One other question is, what insights are you most interested in with this year's competition?
You know, that's a great question. I don't know if there's, obviously the theme is special teams. The advice I would give is not necessarily any specific insight, but if you're going to do an insight, if you're going to participate, I would suggest, rather than trying to solve 10 problems at once and say, here's a metric that looks at punters on punt plays, and here's another metric that looks at field goal kickers, and here's another play that looks at kickoff. Here's a like a metric that a bunch of metrics for a bunch of different things. I would highly suggest looking at one specific player and not one specific player, one specific position on a specific play type, and really digging deep. Definitely teams who and analytics staffers from teams are going to be the judges. So those that are the judges definitely gain a lot more when it's something really in depth that solves one issue, rather than trying to solve special teams with tracking data all in one submission. So I would just suggest whatever you do, and there's plenty of things you can look at with punting, kicking. Honestly, even if it seems simple, that can go leaps and bounds if it's done well. Just don't try to tackle every single problem. Just find something that you're interested in and that you can do well, and just tackle that really, really well.
Awesome. Is it okay to ask if?
Oh, I'm sorry. Go ahead, Rachel.
I just want to check with you, Tom, if it's okay to ask a few more now.
Yeah, sure. Are there any specific to this one? Otherwise, I can jump to the next thing, which I'll probably go through a little bit faster. Maybe skip the cleaning steps and just focus on the results.
Tom, there's been quite a bit of discussion in the chat about the Z coordinate, especially as it relates to the animation that you created. Can you talk a little bit about what's available, what isn't available for that?
Yeah, so unfortunately we don't measure the z coordinate with our tracking data currently, but I would say there are definitely ways to figure it out, whether it be looking at the event data, so that there's events that are tagged like field goal kick, field goal make, field goal miss, or kickoff land. That, as well as you could use the PFF hang time data to get a sense of when it landed. So I would say that there's certainly ways to use to infer the z coordinate. You know the speed, you know how long it was in the air, you know where it landed. You can get a sense of what the z coordinate is using. And I'm a physics person, so I like physics a lot. So using kinematics and I think there has been some work on that, maybe in previous big data bowls, but definitely that's something that could be inferred using some of the other variables. But unfortunately, it's not measured on site.
Thank you. I see a few people have put their name when they asked the question on Slido, so I'd love to turn the mic over to you to have you ask those, if that's okay. Amelia, I see you asked a question about different factors pertaining to the kicker. Would you like to ask that one live?
Sure. Hi. I was just curious how you thought about using age as a factor in these kickers and how they perform.
You know, not in this specific analysis, but that's definitely something that could be explored, and maybe especially, although it's only 3 years, which maybe isn't a huge sample size of years, this is the first time when we have multiple years of data. So maybe that is something to look at. But yeah, definitely something that you should think about exploring. And you have the birth dates from the players' data, so you should feel free to explore that.
Awesome. Brian, I see Brian Filker had another question as well. If I could pass the mic over to you.
Yeah, of course. Yeah, Tom, I was kind of curious on factors such as wind direction and speed. Those are kind of things you're trying to find, like a uniformity, in setting the kick direction, different stadium constructs, and how I always think of, Phil Dawson always mentioned with the Cleveland Browns, how he had a special flag installed so he could see the wind direction and wind speed to factor into his kicks. Is that taken into consideration at all?
Yeah, so again, not for this analysis, this was sort of built to get people started. Definitely, I would highly suggest, if you're going to look at that and you're interested in weather stuff, definitely go for it. I posted on the Kaggle website, so external data for this competition is totally free to use as long as it's publicly available to everybody for free. So I would highly encourage you to seek out weather data. I posted some on the Kaggle site and tweeted some, and it's also on my GitHub. But also there are plenty of other sources you can use for weather data. So feel free to use it. And I would, if you are participating in that if you want to use that, I would highly encourage you to do so.
Thanks.
Awesome. Mitch, I know that you're monitoring the Slido as well, and just wanted to check, are there any other questions you think we should ask now?
One of the questions was about statistical modeling techniques. And Tom, maybe I'll just throw my 2 cents in here to kind of underscore something that you said about finding something particular and doing it really well. So just as what you just described, for instance, didn't necessarily include any sort of sophisticated modeling technique. It required really good intuition, understanding of the sport, and some understanding coordinate information. And you're able to see a really meaningful metric as the output. So for those of you who are maybe thinking this is a mountain of data, I'm going to apply this super sophisticated modeling technique, by all means, have at it. There's certainly things to do there, but at the same time, really good intuition and understanding of the game and just some understanding coordinate information, you can have some really meaningful output as well.
Yeah, absolutely. I would echo that.
Awesome. Thanks, Tom. I'll pass it back over to you to continue the presentation, and then we'll save the rest for the end too.
Perfect. Yeah, so I'm probably just going to skip the cleaning and the reading data for this second thing, but I'll briefly go over what the metrics about and talk about the modeling technique. So another thing that another demo that we put together, we looked at speed on kickoff plays. So the kickoff special teamers are planned to sprint down the field, try to kick off to the end zone and try to make a tackle, and they try to run as fast as possible to prevent the return team from gaining yards. So for those of you who know football, you know the kickoff. So essentially, when the kicker kicks it off, all the other members of the kickoff team are sprinting as fast as possible. One thing that we can look at is what is their speed? How fast do they go on these plays? So I'm going to skip the cleaning and the reading, although those are very important. Just sort of talking about a type of model that we like to use at the league, and it's also just something that applies here. So essentially, we assume the data has already been cleaned. Basically, what we have is we have a game ID, a play ID, an NFL ID. So a given player on the kickoff team and their max speed during the play, and we're going to try to model that. And also we also have surface, which we merged, which is also part of it. So we're going to create a mixed effects model, and a mixed effects model sort of to account for lack of independence among observations. We assume that each player is sort of from the same population of players, and no player is going to be drastically faster than another. So we assume that each player is from a distribution, and as they sprint more, as we get more observations, we sort of have more of a posterior and can assume where that player might be. If they have few observations, we assume they're probably close to the overall league mean in terms of speed. So we're just modeling the max speed, taking into account the NFL ID and the surface. Again, I'll try to go a little bit quickly through this. We have a model that takes into account, we assume players are a random effect, meaning if we have a lot of information about them, we're going to sort of believe what the information says. Otherwise, if they have one observation, we're going to assume that they're probably closer to the mean, and that's just to prevent a player with one really good observation to be leaps and bounds better than a player with very few. And if we were to do a sort of a dummy variable or a factor variable for each NFL ID, we'd probably overfit and have a ton of variables. So this is just a way to have sort of a value for each NFL ID and not overfit. So we're going to look at the summary of the model. We have fixed effects, which are the surface. That's a pretty typical thing. That treats as sort of like a normal factor type variable. And then we have the NFL ID, which is the intercept. That's again, we're assuming it's from a population where all the players from that population are more or less the same and will have more or less the same speed. We can plot the results of the model, sort of the player effects, and again, this is just to take into account the fact that the players will have a max speed effect that is based on the fact that they're running across different surfaces, and that's another advantage of it. And I'm realizing I'm not explaining this well. Each player will have an effect that is based upon how they've done across different surfaces, but this modeling technique takes into account each surface. So perhaps it's really hard to run fast on grass. Players that run fast on grass will have an adjustment to their coefficient. It's kind of like any other model where each sort of variable will take each other into account in order to have a a value that makes sense. So what we get based on taking into account the surface, figuring out what the effect or the intercept will be for each NFL ID in terms of figuring out what their max speed will be. We have player effects that can kind of be thought of as plus or minus what you might expect compared to the average player on the average surface. So the thought is Matt Cole will typically be about 1.7 yards per second faster than the average kickoff coverage player on the average surface. This is the top 25 of all the players in this effect. So y-axis is player name, x-axis is that plus or minus player effect, and we have the top 25 in this metric. So Matt Cole is the fastest, where Devin Duvernay is the slowest of the top 25, but he's still in the top 25. So this is just a way for us to take into account surface and really measure how well we expect these players to do compared to the average player. This is what the entire population looks like of these player effects. So it's a left skewed distribution with mean 0, standard deviation around 1, and maybe actually more like around 0.5, and the distribution will give us information on what this looks like, and you can see that the difference between the best player and the worst player isn't necessarily that large. It's about 2 yards per second. The last thing that I'm going to sort of touch with this part of the presentation is one thing that I would highly suggest people do if they are planning on participating in the Big Data Bowl is to analyze a model's stability to make sure that, okay, if this model predicts well for the first season, how well will it do in the second season? Or if this model predicts well for the beginning of the season, how well will it do for the end of the season? We don't want to, it's a way to make sure that your results are making sense and are picking up on something. So one thing that we can do here is we can do the exact same process before to get the player effects, but do one model that is only weeks 1 to 8, do another model that is only weeks 9 to 17, and again we have the NFL ID, the display name, and their effect, NFL ID, display name, and effect. So we have 2 different models, only using subsets of the data, and we can merge them together and compare them using a sort of an XY plot. This red line is y equals 1. So if everything perfectly goes through that line, then that means we have a perfect fit. If anything is a little bit off, then we're not getting a perfect fit. Based on the fact that we sort of see, obviously, Trey Flowers here at the bottom seems a little bit off. Basically, since we're seeing a pretty good fit line, we feel pretty confident. And then we can do we can remove the outliers. We feel a little bit better. Yeah. So then we can look at the R squared. But yeah, this is just 2 things that I would say to take away from this part is just, one, really analyzing stability is a good way to make sure your model is doing what you hope it does, and 2, definitely there's a lot of different modeling techniques to look at here, and definitely take into account if you're going to do something with a bunch of players, doing a model with 300 different players, each having their own variable, can be difficult, especially because each of them are going to have different number of observations. They'll be playing different number of plays. They'll have different roles. They'll be on different teams. So really thinking about that stuff is important. So yeah, I'll pause again, and I understand I probably went through this section a little bit fast. So hopefully people were able to catch stuff, but I'll pause again and I can answer some questions. I can answer through 1:15. Hopefully I won't get kicked out of the room that I'm in. And if I do, I'll just have to turn off video for a sec and I can jump back into answering questions.
Thank you so much, Tom. That's awesome. And yeah, no worries if you have to turn off video and run to another room. Thank you for taking the extra time. I see there's an anonymous question that we may have touched. I think you touched upon this one already. Is environmental data included or allowed in this big data bowl?
Yeah, it's not necessarily included with what we're providing, but it's certainly allowed as long as it's publicly available, free to all. So definitely allowed if you can find something that you want to use.
Awesome. Josh Goldberg, I see you had asked a question in Slido around peak age. Would you want to ask that question live or add any context?
Sure. I think Amelia kind of had a similar question to it before, but I was just curious if you had looked into any of the kind of distribution for how the metric offset by center, what that looks like for players over the course of their career, if that kind of if there's a certain peak age to when players are, have the lowest absolute value there, kind of what that looks like.
Yeah, no, I have not, but I would just say that's a great big data bowl project if somebody wants to take what I was doing there and take it a step further. We really like the data we provided was 2018 to 20, but honestly, that's essentially all the data that we at the league have, because that's when it was really being recorded. So realistically, no, I probably the coolest thing about this data is answering questions. Because it's so new, you might be one of the first people, if not the first person to answer that question. So no, I didn't look at it in this analysis, but I would highly recommend anyone who's interested in the big data bowl to look at that, because I think that'd be a cool project.
That's great. Thank you. Let's see, going over to Slido. For the XY coordinators, how does it work with Sidelines? And Zach, I see you actually asked this question, if you want to jump in and add some context there.
Hi. Yeah, I was mainly looking at kick returns and punt returns. And of course, quite often they run it over to the sideline. I see that it starts with 0 and 0 on the home sideline. I presume it just goes into negative coordinates.
Yeah, that's exactly right. So if you're a returner and you run out, if this mouse is the returner and you're running out right here, you're probably going to be around like -1, -2. And then if you go above it, you're going to be above 53 1/3, which is where the field ends. It'll just be above 53 1/3. And if you're out of your own end zone, you'll be negative. And if you're above 120, you'll be above 120.
Perfect. Thank you very much.
Yep, absolutely.
Thank you. And I see a few people had asked questions about where the data is and also how to access the code. And Mitch had shared the link in the chat window, so you can access that there.
Yeah, and I tweeted out the code that I shared, as well as the link to the Big Data Bowl for my Twitter @DataWithBliss. So feel free to go on there, and all those links are going to be available. And yeah, you can also just Google Kaggle Big Data Bowl 2022. All of this will show up.
Awesome. There's a broad question as well, which I think is awesome to ask all of our speakers, but they asked, what is the best advice or courses for someone who has little understanding in R to develop better skills? And everybody in the audience, feel free to share examples in the chat as well, but I'll ask you this first, Tom.
Yeah, so I would say a lot of how I learned R was just, I did a lot of learning sort of by doing, and maybe hopefully that helps the question. Maybe that doesn't answer the question completely, because I don't know if I have a specific tutorial or anything that I lent on, but essentially I think the first thing I've ever done in R, it was a class I took in undergrad, and it was, I just, you could do a project kind of in whatever you wanted, and I just said, oh, I'm interested in, I did something in basketball, I'm interested in basketball, I'm gonna just do something. And if you do something that you're interested in with R, or the more you do it, it's going to be easier for you to keep at it, because you're going to be interested in the results, you're going to be interested in the project, and then by the end you're going to get a little bit better. And if you keep doing stuff like that's interesting to you, eventually you're going to get very comfortable with it. And it's not easy. I definitely didn't learn R overnight, and all this code took, I mean, I think I've probably been using it for maybe 5-6 years now. All of it took like a lot of practice, but anyone can get there as long as they keep at it and keep practicing and keep getting better.
Awesome. Thank you. And I was just adding into the chat as well. I'd see a few people are sharing really helpful links. Also on the R for Data Science online learning community, I just put the Slack link to join. We do have a sports analytics channel there, which could be a great place for people to connect after the fact as well, and like share resources there too. Amelia, I see you have another question that's been upvoted a bit as well. Can I have you ask that one live too?
Sure. So I was just curious if you took into account like the number of starts a player had, like on a kickoff return, for example, and how that went into account in your model and like the accuracy of it.
Yeah. Again, I mean, this was kind of a bit of a simplification, sort of a quick thing. And I would, maybe I'll sound like a broken record. I would suggest, like, I have not, and I think that's something that would be interesting to look at. So definitely, if you're thinking about a big Dateable submission, including trying that with your model, or building off of what I did here and adding that is definitely something to think about.
Awesome. Stephen Hill, I see that you had asked a question in the Zoom chat earlier on vertical positioning data. Do you want to jump in and add some context there?
Sure. I think Tom might have addressed that, but definitely would be great to have vertical positioning data. But I think you mentioned that you didn't have it, but it might be able to be inferred.
Yeah, that's what I would say. And honestly, I guess how I would suggest doing it is there's an event tagging of when a kickoff or when a punt was occurred, or when a field goal was kicked. And even if you can't, if the event tag is off, you can kind of infer based on when you see the ball start to move in a given direction. I would use that combined with the PFF hang time variable, and you can figure out how long it was in the air. And let me think, maybe you can, and if you don't even, maybe you can just do it using the hang time variable in kinematics. Yeah, you can actually just use the hang time variable in kinematics to get a sense of what the Z coordinate is, because it, and not to get too physicsy here, but we can assume that gravity is constant, and you can figure out if it's in the air for this long, and then it will feel a constant acceleration of gravity. Then eventually it will, like you can figure out, like, if it was in the air for this long, what gravity is, it had to have reached this Z height, and then you can tie that to the time, and then once you tie it to the time, you can get an X and a Y. So I would Google kinematics, and there's a way to infer doing that. Great,
thank you. I see a few people had also asked about where the recording will be shared. So I just shared a few helpful links there. We do have tomorrow off at RStudio, but I'll share the recording by Friday afternoon to the RStudio YouTube. And I put the link there in the chat, and then also on the meetup page and on LinkedIn too. Tom, are you getting kicked out yet?
I don't think so. So yeah, I'm
okay. Awesome. There's an anonymous question that was positioning of cameras on the field for video capture an important factor for this?
Yeah, so as I might have said at the beginning, there are several leagues, including NBA, NHL, I think, and soccer, that use video tracking data. The NFL isn't one of them. It's based off of chips that are located in the shoulder pads of each player and in the ball. So camera angles was not a factor in this at all. It's more based on a signal from the chips to the processor.
Great, thank you. And I see a few more questions are coming in on the Zoom chat as well. I'm trying my best just to organize them from the Slido, but feel free to raise your hand if there's a question I've missed and you want to ask live too. But
Oh,
one
I
other,
see one. Oh, go ahead.
oh, you see someone?
I was going to say, someone asked if stadium nets are standard. The question, yes, they are. But sorry, go ahead.
Okay, perfect. The other question, anonymous question was, how does hang time work with onside kickoffs? Is there any description or data around the type of roll bounce of onside kicks?
Yeah, let me try to think. So in the PFF data, I would suggest looking at kick contact type for onside kicks. I don't know. Again, PFF is I don't know the data, that data, like as well maybe as I know the tracking data, but I would check that. I'm pretty sure the hang time would just be how long until, I think the definition is it's how long, and once the ball goes into the air, how long until it touches the ground. Obviously, as some would know with onside kicks, sometimes you will kick it in the air and then have it land and then bounce. So the hang time will be rather low. So in that sense, it might be a little bit difficult to figure out exactly what's going on with like the Z coordinate on onside kicks, assuming if there is a bounce. But I would look at kick contact type. In addition to, hang time and kick contact type are probably your best bet. But admittedly, it might be information that's hard to get.
Thanks, Tom. I see there's also some conversation going on in the chat around Wilbert's question around what are good free NFL data sets that are available to the public and can be used.
Absolutely. Yeah. So NFL Faster is a package that has a lot of really good free data sets. And I think a lot of questions I might have seen on Twitter and in the Kaggle discussion page before were like, oh, how do we figure out who the fumbling player is? How do we do that? And honestly, I would just suggest using NFL Faster, and they merge very easily to the data that we're providing. They merge on game ID and play ID. So that's something I would recommend. I would recommend, the weather data that I provided also you can use with game ID and play ID if that's of interest. I think those would probably be the main two, but there are tons of stuff out there. And then the package that Ben Baldwin wrote, I think could also be helpful.
Wonderful. I think we've made it to the end of the Slido questions, but I just want to do a double check from the Slack here. And I see Matthew, you asked, is there a way to access the chat transcript after the meeting? I will go through that and then copy the links, and I'll share that in the YouTube recording and then in the, on the meetup discussion page too. I'm not sure if anybody, I'm allowed to download the chat. You might be able to. If you see 3 dots, you can press save. It might just only be available to me.
And Tom Mock, I think, said something. I would definitely agree looking at NFL Reader. I think NFL Faster and NFL Reader are connected, but I would absolutely recommend looking at NFL Reader too. Because NFL Faster, I think, is better for live data. But NFL Reader also is a good one.
Awesome. I'm just going to open it up if anybody wants to raise their hand and ask a question if I've unfortunately missed something from earlier, or if you have a new question you'd like to ask before we end today.
Excuse me, I've got a question if it's possible to ask.
Sure. I
was wondering, with punt returns and kick returns, is it possible to perhaps do expected yards rushing yards over expected, and use the NFL data that's available that they already have from models before, or would we have to build it ourselves?
I'm guessing, let me see, is Mike Lopez on? He's probably a better person to ask, but I think it probably, definitely Mike, go ahead.
Yeah, I think that your best 2 steps, Zach, are the initial expected rush yards on Kaggle from the 2020 Big Data Bowl, that framework is there. I think probably more aptly in terms of copying and pasting code. Ben Baldwin, who Tom mentioned earlier, he looked at using that same framework with defensive coverage schemes, so like man versus zone. And I want to say his code is public. Those are your two best bets. I wouldn't be surprised if somebody this year goes and also replicates it. If you're trying to be that person, I think those two places would be where to go, and get started there.
Thank you very much.
Of course.
Thank you. I'll open it up to any other remaining questions too. Well, thank you all so much for joining, and thank you, Tom. That was amazing. I really appreciate your time and sharing all your insights with us. Just a reminder, we'll share all the links and the recording up to the RStudio YouTube and on the meetup page and on LinkedIn. But if you ever have any questions at all or can't find something, feel free to reach out to me. You can just email me, rachel@rstudio.com, or on Meetup and LinkedIn. Thank you so much, Tom. Really
Thank you. Thanks everyone for listening today.
Have a great rest of the day, everyone.